In the next clip, you'll see in detail how to construct a sine curve on a horizontal line. The way that's done, we first construct a circle, then through the center of the circle we draw a line. I drew that line horizontal. It could be drawn in any direction. You can rotate this any way you wish. And then we draw a line perpendicular to that line, again through the center of the circle. The first line divides the circle into 1, 2 equal arcs. The second line, along with the first, divides a circle into 1, 2, 3, 4 equal arcs. We can then bisect this angle, or alternatively bisect the line segment connecting this point with this one, to arrive at a line segment that intersects the circle here at a point where the arc distance here is equal to the arc distance here. And that arc distance can then be repeated another time, another, for a total of 8 times around the circle. So now we will have divided the circle into 8 equal parts. Okay, this angle can be subdivided right here into 2. Simply using compass and straight edge, construct the bisector of that angle, obtain this point. And now we will have divided this angle here into 4 equal parts, and we'll have an angle or an arc which can be repeated a total of 16 times around the circle. If we divide that in half, we get an arc that can be repeated 32 times around the circle. So we're subdividing the circle into rational number multiples of the circumference, because 1/2, 1/4, 1/8, 1/16, 1/32, those are all rational numbers, and we have that rational multiple of the circumference in each of the corresponding arcs. Now, to construct the sine curve, we simply take 2 points on our line, the first line that we constructed, that we extended out here. Take 2 points on that line, and then divide that interval into half, and then divide this interval into half, and divide this interval into half. Now, the distance between these 2 points will not necessarily be equal to the circumference of the circle, but it'll represent the circumference of the circle, so that each of these 4 segments will represent the arc corresponding to 1/4 of the circle. And then here, where I've divided this arc into 8 equal parts, we can subdivide this interval into 8 equal parts. For each of the points that we get in that subdivision, each of the points that we're going to get in that subdivision will correspond to one of the points on this arc. And above each of these points, perpendicular above, in a direction perpendicular to our horizontal line, we're going to construct a point whose distance from that horizontal line is the same as that of the corresponding point on the arc of the circle. So, first point is this far above the line. Well, here's the point that corresponds to this, and we're the same distance above the line here. And we simply construct those points. Now, if you want to see that in more detail, view the longer video. But that's what's done. Then, having done that for the first quadrant, we could do the subdivision around each of the other quadrants, but instead of doing that, we use a symmetry. Okay, the distances above the axis for these points are repeated in reverse order as we go from here to here. And you should understand what that means. If not, look at the longer video. Meaning that if we draw a line right here through the point that corresponds to the first quadrant, the end of the first quadrant, we can reflect each of these points through that line. Reflection means at perpendicular to the line, equal distance on the other side of the line. So this point reflects to this point reflects to this point, and all of these points will reflect over here. Then we can continue around this part of the arc. Well, it's as if we take this arc here and flip it around like so, so it's upside down. The same values are going to repeat, but they're going to be below the axis. We can achieve that, and you can figure out, prove this to yourself. If we take each of these points and reflect through this point right here, and this point being the point that divides the arc into two, the point corresponding to this point on the arc of the circle. Okay, so reflecting means we draw a line from this point through this point, and then at an equal distance on the other side of the point, we make our mark. We do the same thing here, line from here to here, and then extend it, and then make our mark. And we do that with essentially every point on this line. I've only drawn a few of them. And then we construct our curve through those points.